Welcome back, Mindsetters. As you know, we are doing 2D trigonometry for grade 11s. It has reached the point where we are going to take some questions because we know that you guys always have so much to ask and know, and we love it. Hey, Natasha, do you want to hear those too?
Yes, okay, let's go for it.
Okay, sure. So Edwin asks, how do we calculate the area of a right-angled triangle?
Okay, so the area of a right angle triangle, and guys remember it only works if, as Edwin said, it's a right angle. Okay, if there's no right angle, you can't use this method. But the area of any right angle triangle is a half of the base times the height. So it's a very basic, remember when you first started learning geometry in grade, I think it was grade 8, they teach you this formula. Area of a triangle, half base times height. Okay, so that's for any 90-degree triangle. Is there another one, Katleho?
Yes, there is. There's one by Takalani who asks, what type of angle is an exterior angle?
Okay, so once again, these are more geometry questions rather than trig questions, but anyway, we'll have a look at it. If you're talking about the exterior angle, because remember you can get exterior angles also of quadrilaterals. But we're going to focus on triangles because that's what 2D trig is looking at. If you have some triangle like that, all right, your exterior angle is the one that's formed on the outside of this. So if we call this AB, okay, and there up to there it was C. So if we extend length AC all the way to B, then the exterior angle is the one that's formed on the outside of this angle C. Okay, so it's basically if you have a triangle, it's the one on the outside of the triangle. And if you're trying to remember grade 10 geometry, remember the exterior angle of the triangle is equal to the sum of the interior opposites. But it's not really for our purposes right now, but it's good to know these little facts and little theory bits from geometry when you're doing trig. All right, but I think we're ready to do our last question.
Okay.
All right. Okay, guys, this is quite a long one, quite an involved one. So let's fly through it. Okay, we are told that a piece of land has the form of a quadrilateral ABCD. They don't tell you what type of quadrilateral, so they haven't said it's a parallelogram, so you can't make any of those kinds of assumptions, okay? It's just a four-sided shape. They tell you that AB is 20, BC is 12, CD is 7, and all of this is marked on the diagram. AD is 28 meters, angle B is 110. The owner decides to divide the land into two plots by erecting a fence from A to C. So our fence is A to C, and we've got this now divided into two triangles. Because remember, if we're dealing with trig, trying to solve for sides and angles, we're always going to have to divide things into triangles. You have to. Those are the only rules that we know to work out the lengths of sides. All right, so we've divided this into triangles A, B, C, and triangle ACD. We've got quite a lot of information. There's not much that we can put down at the moment just looking at what they've given us. So we have to read the first question. They say, calculate the length of the fence AC correct to 1 decimal place. Okay, so if you have a look at fence AC, it falls into two triangles. It can either be ABC or ADC. It's the joining side. So how do you know which triangle to start in? And hopefully all of you have answered at the screen because I've already told you. You always work in the triangle with the most information. So that means we have to work in triangle ABC. We have no option because that's the only triangle with an angle. So it's got the most information. Okay, so we've got, what do we have? We've got two sides and an included angle. And we're looking for the side opposite to that included angle. So that to me means that we need to use the cos rule. All right. So I'm just going to write it down. I've got my little piece of notes here just so I can avoid writing on that diagram. I'm going to write it way at the bottom. So this is A. And remember the point here is we're looking for AC. Okay, so using the cos rule, we can say that AC squared is equal to BC squared, which was the given side, plus AB squared, which was the other given side, minus 2BC times AB, and then cos of the included angle, which in this case was 110, so cos of 110. Okay, so let's just go up to that diagram and show you that all we're doing is just applying the cos rule. So we've got AC squared is equal to BC squared plus AB squared minus 2BC times AB, cos of the included angle. Okay, so now all we've got to do is put in our values. So therefore, AC squared is going to be equal to 12 squared plus 20 squared minus 2 times 12. And all I'm doing is just replacing BC and AB with their lengths times cos of 110. Okay, so once you've gotten to this point, 12 squared plus 20 squared minus 2 times 12 times 20 times cos of 110, the rest of it is really just calculator work. So make sure that you know how to do this kind of question on your calculator. Guys, because this is quite a long question, I've already worked out the answer, I'm going to just write down the solution, but please make sure that you know how to use your calculator to work this out. Okay, so if you do all of that on your Casio calculator, and remember they said here we want it rounded up to 1 decimal place, your answer is going to be 26,6 meters. Okay, so AC, okay, because up to there we were looking for AC squared, so therefore we get that AC is 26,6 meters. So that's this one here, 26,6. All right, so now we've got AC. Still we don't have an angle, so there's not much more we can fill in. All we can do is just write in the length of AC, which is what we've just worked out. The next thing says, calculate the size of angle BAC. BAC, so that's this little one here. All right. So there, guys, it sort of restricts you because really that angle only falls in triangle BAC, so we have to work in that triangle. What do we need to work out? We need to work out an angle. We've got 3 lengths now, and we've got 1 angle. So we could use the sine rule. Okay, the quickest way to do this is using the sine rule. All right, so using the sine rule, remember we're looking for angle A, so we can set this out as BC using the sine rule over sine of, and I'm going to call it A1 because it's actually divided into 2 little pieces. So BC over sine of A1 is equal to, now you've got to decide, do you use side BA or do you use side AC? Well, it's actually already decided for you because you need to use the side where you know the opposite angle. So that means we have to use AC because that's the only one where we know the opposite angle. So therefore it's going to be equal to AC over sine 110. Okay. If you wanted to have the sine of A1 in the numerator, you could have obviously had this formula flipped over. It doesn't matter. Either way, you'd get to the same answer. Okay, so what we're going to do, remember we're looking for angle A1. We're going to cross multiply, so we'll get AC times sine of A1 is equal to BC times sine of 110. Okay, so if I'm looking for sine of A1, I'm going to get sine of A1 is equal to 12 times sine 110 all over 26,6. Okay, guys, and then once again, we are running out of time, so I'm not going to be able to do this on the calculator. You do that on your calculator, 12 times sine 110 divided by 26,6. You will get a ratio of 0,423 921. And remember, because you're looking for an angle, you've got to go shift sign of that ratio on your calculator, and therefore you will get that angle A1 is equal to 25 degrees. Okay, and I think they said round off to the nearest degree, so therefore we've got A1 is equal to 25 degrees. And I think that's going to be all that we have time for.
Yes,
Katlego.
it is. Unfortunately, time always goes so fast when you're having fun. So thank you, learners. You guys were absolutely fantastic today. Keep helping each other, guys. And thank you also to Liberty. And we'll see you next week again for same time, same place for grade 11 mathematics. Bye-bye.